Thank you for joining this lesson. We're going to discuss translation vectors and equations of a straight line. Number 9, we are told that a translation t, which is equal to 2, 3, maps A onto A prime, negative 1, 7. Then the image of B under the same translation is B prime 2, 13. Write down the equation of the perpendicular bisector of line AB in the form y equals to mx plus c. Alright, so what you're supposed to know is that when we take an object plus a translation vector, we usually get the image. Therefore, in this case, we can talk about the unknown A, which has x and y. Then the vector for translation. This one is giving us an image of negative 1, 7. Therefore, we can remain with x. When we take 2 to the other side, that becomes a negative 3. We can also get y. When we take 3 to the other side, this becomes 4. Therefore, the coordinates of A are negative 3, positive 4. Again, for B, you see under the same translation, remember B is unknown, but the translation vector is known. This one is giving us 2, 13. Therefore, we can get x for B being 0 and to y being 10 when we take 3 to the other side. Therefore, the coordinates of B are going to be 0, 10. Now we are finding the equation of a perpendicular bisector. An equation of a perpendicular bisector to AB. That means we are first of all going to find the gradient for AB. So gradient for AB, I'll call it gradient 1, will be given by change in y. So we may take 4 minus 10. Out of change in x, I will take negative 3 minus 0. So this is going to be negative 6 over negative 3, giving us 2. Now, a perpendicular bisector to AB, if AB is having the gradient of 2, then its perpendicular bisector will have a gradient such that when the two gradients are multiplied, we get negative 1. So the other gradient should be the reciprocal of this one and with the opposite sign. Therefore, the opposite sign is negative and the reciprocal is a half. So that becomes gradient 2. Now, the other thing to find is a point where this perpendicular bisector is passing. If it's a perpendicular bisector of AB, it means this perpendicular bisector is passing at the mid of AB. So the midpoint of AB is going to be the midpoint of AB. So with A and B, for us to get midpoint, assuming midpoint P, we will need the first x plus the second x, and we divide them by 2. Then we take the first y plus the second y out of 2. Therefore, this is what we're going to do. Let me use the space here. So the first x is negative 3. The first x is negative 3. And the next x is 0. So this is what we're going to divide by 2 now. Then the first y is 4. And the next y is 10, again over 2. So the coordinates of the midpoint of AB are going to be negative 3 out of 2, which is negative 1.5. Then we have 4 plus 10, 14 over 2. This is 7. Negative 1.57 is the midpoint, or the point where the line passes. Now we're going to express our gradient using one point where it passes, and we let another coordinate be xy. Therefore, we're going to say negative half equals to change in y. So y minus 7 out of change in x plus 1.5 because of minus negative 1.5. So now at that point we can cross multiply. I will use the space here. So I'm going to have 2 multiplying with y minus 7. That becomes 2y minus 14 equals to negative 1 by x and also negative 1 by 1.5. So it becomes that. Then we shall remain with 2y equals to negative x. So this is going to be plus. When we take 14 and we subtract 1.5, we get 12.5 positive. So now we can remain with y because we've been told to put the equation in this format. When this is divided by 2, I'm getting a 6 1/4. So this is the equation in the desired format.